Welcome to CATS Tutorials. In this video, we're going to be covering practice problem 2.10. Now we are asked to find the equivalent resistance across terminals A and B or AB. So you can basically start anywhere. I can see 2 points where you can start at. You can basically start up here by saying 20 in parallel with 5 and then reduce that. Or say 18 in parallel with 9. So let's do both of them. So we're going to collapse both of these and then find a new circuit which is simplified and then continue from there. So 20 in parallel with 5, which we have up here. Let me use a different color. Let me use a different color to show that they share these two nodes. So 20 and 5 in parallel because they share these two nodes. And 18 and 9 also share two nodes. And therefore they're also in parallel. Now let's continue. Let's continue. So 20 in parallel with 5. So using the formula which says if you have resistors in parallel, two resistors in parallel, R1 and R2, this formula is there in the textbook, Fundamentals of Electric Circuits, Chapter 2. So we're going to use this formula. So in this case, we have 20 and 5. So 20 multiplied by 5 divided by 20 plus 5. So that's 100 divided by 25. That should give you 4 ohms. So all of that, these two, can be collapsed to 4 ohms. And now 18 in parallel with 9, we do the same thing. So 18 in parallel with 9. You shouldn't be faced with the configuration of the circuit or how it looks, as long as you know the rules that say if resistors share two nodes, then they're in parallel, and otherwise in series, or neither parallel nor series. So 18 in parallel with 9 will give you 18 multiplied by 9 and divided by 18 plus 9, which should give you 6 ohms. And now moving on, we now redraw the circuit with these two values which we just calculated here. So we replace this bit where we had 18 and 9 in parallel with 6 ohms, and we keep everything as it is. And we come here, replace the top bit, which was 20 in parallel with 5, with 4 ohms. And we now have 2 ohms down here. And finally, we have 1 ohm over there. So, and we have 1 ohm over there, not forgetting 20 ohm, which goes through there. So now you can say 4 and 1 are in series. So 4 plus 1 is the equivalent of those two. So we have 5 ohms. So that 5 ohms is now in parallel because it shares two nodes. It's now in parallel with the 20. So collapsing the 5 in parallel with 20, we have 20 in parallel with 5 again, which we found before as 4 ohms. So we can just take that answer from there. So now redraw the circuit of 16 ohms. We have the 6 ohms still intact. And now the 5 and the 20 in parallel has now been collapsed to 4 ohms. It's now been collapsed to 4 ohms. And down here, we still have the 2 ohms. So the 2 ohms and the 4 ohms are in series. So we can just simply add those up, which give us 6 ohms. So let's use the same circuit, just erase those two and put 6 ohms there, which is the equivalent. And now we have 6 in parallel with 6, which will give us 3, because 6 multiplied by 6 divided by 6 plus 6, that's 36, divided by 12 is 3. So now we draw the new circuit. Let's just continue from here. So the equivalent of those is now 3 ohms. And now we only have, so RAB is finally equals to 16 in series with 3. So 16 plus 3, and therefore RAB is 19 ohms.